So here we have a 4 kilogram block on a rough horizontal table. We're told that the coefficient of friction on the table is 3/4, and we have to find the common acceleration of the system. Now to do this, I'll get rid of the lines, you can look better like that. Now to do this, what we need to do is we need to look at the few different systems, or how things are going to move. And the first thing to notice here is that we've got a 10 kilogram over here and a 3 kilogram weight over there. The overall acceleration of the system, this is going to go down. This one is going to move this way, and this one has to move that way there. There's no two ways about it. They're all the accelerations, and everything will accelerate at the same rate. That's going to be accelerating in that direction, that's going to accelerate in that direction, that's going to accelerate in that direction. Now the force with which this one will move with is equal to, well, the force is always mass times acceleration. So this force here is going to be equal to 10A. Let's make a bit of space there so we can put in the 10A. This one here, that force there will move at a 4A, and this one over here will be moving up with a force of 3A. So we've got a lot of what we need already here. We can now look at this as two separate systems. You notice that you've got one rope connected from here all the way over to here, and we've got another rope connected from here to here. Now in this case the tensions aren't the same because we've got two separate ropes. We will say that, and I'll just pick a different colour for these, hopefully this will work. We will say that this tension here and this tension here, we'll call both of them S and S, and then I'll change the colour of the pen, I'm going to go with this green here, and we've got this tension here and this tension here, we'll call T and T. And a lot of arrows there already. We've still got to fill in a few more. Now, first one here we can put in, because this is on the block and we're dealing with friction, we know that the friction is 3/4. We need to know the reaction force on the block on the table. So I'll start putting in a vector. We'll put in a few of the vectors for that, and I'll use orange for this. So we have, that should be like that. We have, its mass is going directly down like that, but equivalently we could say that, let's maybe make room there, that its reaction force is up in this direction here. This would be the reaction. Now we've nearly got all the vectors that we need. So that's the reaction. That's equal to the mass times acceleration due to gravity, which is equal to 4g. We need to know that, because for friction is equal to the reaction force multiplied by the coefficient of static friction. So the frictional force this will experience, I'll just put friction there. Friction is going to be 4g times 3/4, which is equal to 3g newtons. That's going to be our friction. Now these questions, they'll look a little bit messy, but they're not too bad. Okay. Now we've got our system. We'll go with this section here first. So I'm going to circle it in red. I'll get rid of that. So all the way over to here, just including that block and this one here. Now I know this also has a mass of acceleration there. I'll put that one in there as well. mg, so the force down there is 3g. Now I know for this box on its own, I can get an equation. I know that 3A is the overall force is equal to S minus 3G. Now, I think it'd actually be easier to skip over and to do the same thing for this one here. Now, get another equation. And for this one, we know that the overall force is 10A will be equal to 10G minus T. The big difference here is that instead of having an A and a T, we've got an A, an S, and a T. So we've got three unknowns. So we're going to need three equations to solve this problem. The third equation is going to come from this system here. Now, I might redraw that so that I can have all the forces and you can see them. We have that block on the table. We know it's going to overall move in this direction here. We know that there's T in that direction. We know there's a force of acting in this direction of S acting in that direction. We also know that it's going to move this general direction, but there's also going to be a resistive frictional force as well. So I'm just going to label these. I'm not going to do them in any other colours. So we know that 4A is the overall force. T is the force that's being pulled along that direction. We know S is a resistive force. It's the tension from the 3 kilogram block. And we know we have a force of friction here as well. Adding all these together, we know that 4A is equal to T minus the force of friction minus S. And if you remember, the force of friction was 3G. So we have 4A is equal to T minus 3G minus S. That's one equation. We've got them here now. I might just put boxes around each, and that's 1 there. That's 2 there. That's 3 there. 1, 2, and 3. So now that we've got 3 equations, we can solve them simultaneously to get our value. Now, what way will we do this? Well, if we just maybe take equation 1, and we can get S is equal to 3A plus 3G. Be happy with that. If I take equation 2, I can write T is equal to 10G minus 10A. If I sub both of these into equation 3, I'll leave everything that stays the same as it is. 4A is equal to, and I'm going to have in black then, T instead of T, I'll put 10G minus 10A. Leave the minus 3G there. It didn't change. It's not changing. But this one is. S is plus 3A plus 3G. Group everything together. Bring all the A's over to the left, all the G's over to the right, and we get 4A plus 10A minus 3A is equal to 10G plus 3G minus 3G. That's equal to 0. So we get 11A is equal to 10G, or A is equal to 10 over 11G. So there's a small mistake in this, and the mistake comes from this here is a minus S, so these two values here should both be minus. So I can do that quickly. Put a minus in there, and so that's 3G. Okay, minus there. And I'll just get rid of everything else and just do this last bit again. Okay, so if you bring all the A's over to one side, we have 4A plus 10A plus 3A is equal to 10G minus 3G minus 3G. We get 17A is equal to 4G. And we get G is A is equal to 4 over 17g. So once we have A, then we can sub back into equations 1 and equation 2, and we can find T and S. So I'll probably leave it at there. It's just a simple substitution, subbing this value into both those equations, and it should work out fine.